कॉन्टैक्ट करो ताले मैं आरंभ कर दूंगा. So Professor Gangrekar will now start. Others will be joining possibly. Almost close to 30 fellows have registered. So let us hope that they join.
Sir.
Very warm welcome to all participants to this 45th Distinguished Lecture Series that is being organized by INAE Bhubaneswar chapter, IIT Bhubaneswar, NISER Bhubaneswar, IMMT Bhubaneswar, and Shiksha Anusandhan University, together with IEEE Bhubaneswar chapter. So it is a joint effort of so many people, but SOA University is actually hosting it. So today in this 45th lecture, distinguished lecture, we have distinguished speaker, Professor Makarand Madhav Gangrekar. He is the director of National Institute of Technology, Puducherry, and professor in the Department of Civil Engineering of IIT Kharagpur. Now, so he has been a visiting scientist to Ben Gurion University, Israel, University of Newcastle upon Tyne, UK, and Marie Curie. He is an UK under Marie Curie fellowship by European Union and has a faculty of various capacity is renowned engineering colleges and research institution. He has been working in the field of anaerobic wastewater treatment, bioenergy recovery during from wastewater treatment using microbial fluid cell and bioelectrochemical systems. He is recognized worldwide as by the scientific community for his research contribution in the development of bioelectrochemical processes, and his research group stand among the top 3 research labs in the world in terms of scientific publications. The first of its kind, MMFC based on-site toilet waste treatment system, bioelectric toilet, developed by him, received wide publicity in electronic and print media. He has successfully completed multinational collaborative projects with European countries, and few of the projects are ongoing. As he has also provided design of industrial wastewater and sewerage treatment plants in India and abroad. He has been working on setting up of wastewater treatment plants to produce reusable quality treated water in affordable cost. At present, he is coordinating one such project jointly funded by European Union and the Department of Science and Technology, Government of India. He has worked as a member of IIT Consortium for rejuvenation what is popularly known as Namami Ganga project. He has been helping various state government, including Odisha, Chhattisgarh, and Jharkhand, and industries for providing wastewater collection and treatment solutions. He has guided 30 PhDs, research scholars, and 65 master students project. He has contributed 309 research papers in journals of international repute and contributed 87 book chapters. His research work has been presented in more than 284 conferences in India and abroad. He has written textbooks on wastewater to water, published by Springer, and edited 3 books published by William, namely Microbial Electrochemical Technologies, Microconstituents,
Macro constituents.
Micronit,
Constituents.
micro
Constituents present. Yeah.
constituents, micro constituents in the environment and microplastic environment. He has received, delivered, invited lectures in the various reputed universities in the world, to name a few: Newcastle upon Tyne, UK, Bremen and Augsburg, Germany, University of Tarnu, Estonia University of California, Berkeley, USA, Hong Kong University. He has visited several countries in the world from USA, Canada, Europe, and Asia. He has received recognition for his research contribution by getting elected as the Fellow of Indian National Academy of Engineering, Vaishik Award 2020, member of prestigious American Society of Civil Engineering, receiving Swachh Bharat Award 2007, Gandhian Young Technology Innovation Award, National Design Award, Best Paper Award by Institution of Engineers India, and Distinguished Speaker Award by Indian Institute of Chemical Engineering. The topic of his lecture is going to be biological and bioelectrochemical wastewater treatment technologies and their efficacies for imparting sustainability to wastewater treatment. So, of course, the abstract of his lecture has been already circulated. You must have seen it. So, of course, in the due course, actually, he will be explaining all these things. So it is not proper for me to read out the abstract, which itself is it is a long excerpt, almost 2 pages. So he will really do that. So Professor Gangrekar,
Sir.
I will now request you to make your presentation. It will be followed by question and answer.
Yes, sir.
Yes, yes.
Yeah. So just, sir, confirm my presentation is visible.
What visible?
Yeah, thank you, sir. Thank you, Professor Damodar Acharya, for giving me this opportunity to present the work majorly that we have done. We have been doing at IIT Kharagpur under various projects, and also the other institutions like IIT Bhubaneswar, ISR Bhubaneswar, CSR Lab, the Shiksha Anusandhan, for organizing this event and the initiative taken by Professor Acharya to invite me. And also thank you, sir, for the elaborate introduction that you have given. So over next 1 hour, I'll be delivering a talk on the application of biological and bioelectrochemical systems for imparting sustainability to the wastewater treatment. So we are all aware that the water scarcity is being faced by almost all countries, and ensuring water security is a global concern now. And particularly in Indian scenario, if we look at every year there is a drop in the availability of fresh water, and it is estimated that what it was 17,500 in 1960, the fresh water availability will reduce to about 5,700 meter cube per capita by 2025. So to meet this gap in demand, we need to find out the alternate sources for the water. And we consider that the municipal wastewater generated in all the cities could be considered as a reliable source, provided we are able to offer treatment at the affordable cost to this municipal wastewater to produce reusable quality treated water. Now, what are the sanitation practices currently being followed in most of the cities in India and many other countries is a centralized sanitation. So, centralized system is used where all sewage generated from all the city is collected through a network of pipe, what we call it as a sewerage scheme, and it is taken far away from the city where it is treated and partially treated or treated, and the treated water is disposed of. Now, with this model in place, if we target the reuse of the treated sewage back to a town, then the third set of pipeline need to be laid. So, which will be a very costly affair. Already we have water supply scheme, already we have sewerage network, and then placing a third network, that too from this far distance, if you have to bring the treated sewage, will be costly affair. And hence we need to go for decentralized sewage management. So sewage generated from a locality should be treated there itself using proper technology choice, which offer reliable treatment so that the treated water reuse can be facilitated. The Indian scenario is not very encouraging. I mean, as of now, as on today, though our government of India is very much aggressive in providing or improving the sewerage infrastructure. However, even today, only about 37% of the sewage generated in this country is being properly treated, and the rest of the sewage is being discharged into the water body, polluting the various water sources wherever the water is getting discharged. This domestic wastewater majorly contains organic matter, the nutrients, other suspended solids, pathogens, and the concern today is the presence of emerging contaminants, the personal care products, shampoo, skin ointments, then all other cosmetics that we are using, and also the antibiotics or the painkillers that we consume. They are not being consumed 100% by the body, and 50 to 70% of it is getting released through the waste. So these are the compounds which are released into water body, preventing its reuse back to the various purposes. So if we are able to provide reliable and proper treatment to this wastewater, then irrespective of the season, the municipal wastewater is an available source. I mean, we all know that many of the states during summer season, when there is a shortage of water, they cut down the water supply, maybe 10%, 20%. So that scenario will not be there, because if the sewage is being properly treated, the municipal wastewater is properly treated, that could offer a reliable source. Majority of you may be aware that typically the wastewater treatment systems, whatever wastewater treatment plant, we classify it into primary treatment, secondary treatment, and tertiary treatment, provided if we are targeting to reuse that wastewater. Generally, when we say conventional sewage treatment plant, it comprises of primary and secondary treatment only, producing treated water not that suitable immediately to be reused back for various purposes. So primary treatment is necessarily meant for removal of floating and suspended matter, and removal of organic or inorganic. Yes, sir. I'm audible, sir. So removal of suspended and floating matter, the primary treatment is employed. And secondary treatment is typically employed for removal of organic matter, which is present in colloidal or dissolved form after primary treatment. And also the sludge generated in the process is being managed while the secondary treatment is provided to the wastewaters. So, as I said, the secondary treated effluent may not meet the reuse quality norms, and hence further treatment, what we qualify it as a tertiary treatment, classify it as a tertiary treatment, is required for further removal of organic matter, for further removal of nutrients, further removal of turbidity, if there is any, removal of pathogens, then color and odor removal. Generally, in the municipal wastewater, the color and odor is because of the presence of organic matter. And if we remove effectively this organic matter, the color and odor will go away. But the major concern and emerging concern is the presence of emerging contaminants, as I was saying, that the personal care products, antibiotics, painkillers. So these are present individually in nanogram or microgram per liter concentration, but put together, they represent in terms of total organic carbon amount about 20 to 30 milligram per liter. And this is where the matter of concern why we are not calling it even after treatment, adequate treatment, the water as a potable water, if these emerging contaminants are present. Because some of these compounds are endocrine disrupting compounds and can disturb the hormonal system, even human hormonal systems, even at much lower concentration if they are present in the water which we are consuming. National Green Tribunal in 2019 came up with very ambitious recommendation that for mega cities, the municipal wastewater should be treated to the pH of 5.5 to 9, BOD less than 10, TSS less than 20, COD 50, total nitrogen 10, total phosphorus less than 1 milligram per liter. And they made a stringent standard for fecal coliforms, which are through the intestine origin. So desirable 100 and permissible 230 mpn per 100 ml. Whereas the Ministry of Environment and Forest has accepted more or less the class 1 city standard, that is BOD 20, TSS 30, COD 100, and total nitrogen 15. However, we anticipate that any new sewage treatment plant coming up for the urban area should meet to the expectation of recommendation of NGT with BOD of 10 milligram per liter, COD 50, and total nitrogen 10 milligram per liter. So the drawbacks of conventional sewage treatment plant, as I said, primary and secondary treatment, whereas in India, most of the sewage treatment plant are employing activated sludge process. So these NGT expectations are difficult to meet with because it still have considerable amount of pathogens, presence of emerging contaminants, nutrients, organic matter, and because the organic matter is present, there is also order, some residual order to the secondary treated effluent. And to facilitate recycling, definitely, certainly we require the tertiary treatment, which should be affordable. We all know the RO could work as an effective tertiary treatment solution. However, if we consider the cost in the Indian perspective, depending upon plant size, if I use RO after secondary treatment, reverse osmosis, so it will cost us about 30 to 50 rupees per kiloliter of the water that we process. So primary and secondary treatment will cost around 10 rupees plus 50 rupees if I add. And if we are able to produce treated water at 60 rupees per kiloliter, obviously there will not be takers for this. So we need to keep cost under control. And for that purpose, we need to select mid or low energy consuming technologies and technologies involving means low cost components so that the periodic replacement of the components, perishable components will also add on to the treatment cost. At the same time, the technology should be robust with the variation in the seasonal variation. It should be able to perform, give the expected performance and reliable performance to facilitate of treated water. For imparting sustainability to the sewage treatment so that the stress on the freshwater demand can be reduced. So we can explore algal technologies. So harvested algae can be utilized as a feedstock for biofuel production. So that will give us opportunity for revenue generation. The last 2 decades, the scientists are concentrating on developing microbial fuel cell-based technologies, so which is a one-step process. While treating wastewater, it also provides us opportunity to harvest electricity directly in the one step. So that way also the electricity can be used on site, and that will fetch additional revenue recovery. Sewage sludge to activated biochar since last 5 7 years, scientists are concentrating more on this aspect. This biochar or hydrochar generated from the sludge has application itself in a tertiary treatment as a adsorbent or other industrial effluent treatment plant, it can be used, or this biochar can be used as a soil amendment for enhancing the crop productivity, or this hydrochar can be used other industrial applications as well. So various application it has, or it can be used as a fuel because it is high calorific material with the calorific value at par with the coal. Then the biomethanation is almost mature technology now. According to my knowledge, in India, we have more than 50 large-size sewage treatment plant employing anaerobic reactor for recovering methane while treating a sewage. We can practice aquaculture also in the partially treated sewage or treated sewage, so that the fish harvested can provide us additional revenue recovery to compensate the cost of wastewater treatment. Recently, since last 10 years, scientists are even coining the microbial electrosynthesis technology, so which utilizes carbon dioxide. On one hand, it treats wastewater, and also the carbon dioxide generated while oxidizing organic matter can be utilized for synthesis of various chemicals for industrial applications. So, sale of chemicals can also impart sustainability. So, the list is not complete. There are many other avenues, but at IIT Kharagpur, me and my research group mainly touched upon these technologies uh, for imparting sustainability to the wastewater treatment. So in 2015, with the funding received from Department of Science and Technology and European Union, we constructed a USB upflow anaerobic sludge blanket reactor-based sewage treatment plant with the capacity of 400 cubic meter per day. And this plant was designed by me, and since then it is in operation. And with the height of 5.3 meter, with diameter 5.6 meter, treating sewage generated from the majorly from the academic area. So very dilute sewage it receives. And we commissioned this reactor in the month of November, which is typically winter season. Hence, it took typically little longer time for reaching to the expected performance. But after 5 months, the plant is started giving satisfactory performance with COD removal efficiency, total COD, COD for those who are not conversant, chemical oxygen demand, the organic matter concentration present in the wastewater we measure with. So this total COD removal efficiency in summer, this plant is demonstrating close to 78%. And in winter, where the temperature drops down, still it is capable to give more than 70% removal efficiency. You can note down the influent COD concentration. It is very dilute wastewater because of the academic campus that we generate. And about annual average COD is around 230 milligram per liter. So while treating such a low strength wastewater, even using anaerobic wastewater treatment technology, it is demonstrating all along a year more than 70% COD removal efficiency, and BOD removal, biochemical oxygen demand removal efficiency is above 80%. So quite satisfactory performance. And one of the peculiar characteristics of this plant is a biomass granulation. Those who are from biotechnology background can understand the agglomeration of the biomass, the different species that are involved in finally converting fermentative reduction of the organic matter to the methane. So all the species, when they are close to each other, staying close to each other, so obviously it enhances the reaction rate kinetics, and that is the reason this plant is giving high performance. Whereas the other USB reactor installed in India for sewage treatment are struggling to give around 55 to 60% efficiency, but ours is one of the best plant which is giving performance more than 70% of COD removal, even in winter at Kharagpur, where the ambient temperature goes down to below 10 degrees Celsius. So that is appreciable performance this plant is giving. Then the USB reactor effluent is treated in the high rate algal pond. This high rate algal pond is typically designed for removal of further removal of organic matter. So USB reactor generate wastewater means effluent with 40 to 50 milligram per liter of BOD. So that this high rate algal pond polishes to give around 20 to 30 milligram per liter of BOD effluent. Then it contributes for removal of nitrogen because of uptake from the algae and also phosphorus. So ammonical nitrogen removal more than 85%, phosphorus removal more than 90% is being demonstrated by this high rate algal pond. And also, since due to growth of algae, when the pH of the wastewater rises to about 9. So that helps in naturally killing the pathogens present in the wastewater. So natural die-off of the pathogens occur to up to 3 log scale. And this way it generates the effluent with 600 to 700 mpn per 100 ml. So in 2015, when the rule was allowable limit was 1000 mpn per 100 ml, so this effluent was suitable to be reused back in for horticulture purposes on campus, and we were using it. But because of the implementation and recommendation of the National Green Tribunal, so this plant, high rate algal pond, is not meeting the requirement of the NGT, and hence then we modified and explore other option for providing treatment to meet the NGT norm. One of the technology that we are demonstrating, this is again with the funding received from Department of Science and Technology and European Union. We are first time demonstrating in India the electrically conductive biofilter. So instead of the wetlands, which is typically used many places in India where the inert media is used for the bed, here we are using coal. So met coke is the product that we are using coal as a media. And the wastewater from the effluent from the USB reactor is applied in the two zone of this electrically conductive biofilter. Each zone has a zero point 0.6 meter depth of the coal media. And while the wastewater trickles over the media, it comes in contact with the biofilm form on the media, and that way the organic matter removal happens. Then the effluent of this electrically conductive biofilter is taken to the anoxic tank for facilitating denitrification, and then the pressure sand filter followed by electrochlorinator and UV combination for effective disinfection, and finally activated carbon filter. So this is the photographs of the plant in operation. So you can see when we are trying with the plant growth on the top of the electrically conductive media, and that is giving appreciable performance. We operated the performance in a different operational mode. So without recycling, it did not give satisfactory nitrogen removal, though the COD removal was appreciable. But with the recycling, two is to one. So treated water we recycle back so that the dilute loading has been applied on the media, and also we annex it with the anoxic zone. So last compartment we made it an anoxic zone to support denitrification. So that way, then we are able to meet the effluent standards with COD removal more than 70%. The percent number may look small, but the influent itself is 90 to 100 milligram per liter of COD. So from that, it is removing 70% COD, so producing 30-40 milligram per liter of COD effluent, which is much less than the recommended standard by NGT. It is also removing effectively nitrogen, and also BOD all along is about 3 milligram per liter or low. So this is the performance result. So pH is well within the limit. COD is also average over 13 months of operation is 23.5. Then TSS 5 milligram per liter. The recommended standard is 20. Total nitrogen 10, whereas we are getting only 5.8. Total phosphorus is around 1 milligram per liter. And MPN, though the recommended norms is 100, it is all along less than 3 MPN per 100 ml. So plant is giving reasonably satisfactory performance. And one of the observation is it does not need any energy. Energy is only required for pumping. And then the rest of the energy need for biological nitrification can be minimized, and that way it can be one of the low cost solution. And for this 100 KLD treatment plant, 100 cubic meter per day capacity treatment plant, we estimated the cost of life cycle cost, considering 20 years life of the plant, around 20 rupees, less than 20 rupees per kiloliter, including everything. So look at the quality of the treated water, which is much superior than the quality available in many of the river stretches in India. The next technology that we are exploring, and first time in the world, this large scale 100 cubic meter per day capacity plant has been tried, is at IIT Kharagpur. And our technology provider is the TU Delft, Netherlands. So based on their initial bench scale experiment, we initially started culturing instead of algae. It is a common raceway pond, but the target here is instead of culturing algae, we would like to culture here purple non-sulfur bacteria. The purpose of replacing algae with the purple non-sulfur bacteria, these microorganisms have a single cell protein, and this protein harvested could be utilized as aquaculture food or animal food, or of course after pasteurization, or it could be used as a soil conditioning agent or fertilizer, or the extracted protein can be used even for many industrial applications. So it has a high product value as compared to the algae. So the plant here we demonstrated as a high rate digester. So it only helps in acidifying the sewage. And this acidified sewage is applied to this plant. Initially, we tried with only 2 meter cube capacity treatment plant with step increase in the capacity. Initially 500, then 750, then 1000, then 2000. And now we are experimenting with the larger plant of 100 cubic meter per day capacity. So this is the interior photograph. I mean, you can see the purple non-sulfur bacterial growth here in this plant. Initial some challenges we face, but with the efforts from our research scholar, we optimize the surface area to the depth ratio, COD is to the nitrogen ratio. So evaluated the conditions, field conditions which are favorable for supporting growth of purple non-sulfur bacteria. And then the performance of this plant is also appreciable. We identified some of the strains of the purple non-sulfur bacteria which are dominant in the plant. And you can see even though the with the co-substrate, when we are feeding artificial jaggery solution, the performance is superior with the protein content in the biomass more than 40%. But whereas when with only sewage we try, it is slightly less than 20%. Still, we are researching on it to enhance the protein content. So this high protein rich biomass, if we are able to harvest, it has a much superior product value than the algae we typically grow in the high rate algal pond. So this experiment is still on. Another 6 months, we have this project ongoing. So final results, we'll try to enhance this COD removal efficiency also, which is right now around 70%, and also the enriched biomass in the high protein content in it. Then alternately, we again tried with the combination of aerobic as well as aerobic MBBR, moving bed biofilm reactor. So partially the effluent generated from the USB reactor, 100 meter cube, we are treating it in electrically conductive biofilter, and rest 300 cubic meter per day, we are treating it in the combination of anoxic MBBR, aerobic MBBR, followed by lamella clarifier. And then we have three-stage disinfection come advanced oxidation process in place, which comprises of ozonation, chlorination, and UV. And we kept a flexibility for the experimentation purpose that the order of this three-stage disinfection can be changed. But over the operation of more than 2 years, more than 3 years now, we realized that the first ozonation, then chlorination, and then UV. So this order helps in optimizing the performance. And finally, then we have activated carbon filter to trap any disinfection byproduct which are formed to produce final treated effluent, which should be suitable for any non-potable reuse. So these are the photographs of the operational plant. And a very ambitious standard here again we set BOD less than 3 milligram per liter, MPN should be all along less than 3. Soluble COD, though the NGT recommendation is 50, we have target of 20 with this combination of treatment chain, which I explained. So and this is the performance, more than 2 years performance of the plant, which will convince you that even the simplest technology without using RO can work. So the soluble chemical oxygen demand is less than 20, that is 18 milligram per liter. Total COD is slightly higher, 23 milligram per liter. Suspended solids is less than 10 milligram per liter. Then the coliforms, all along we are almost most of the days it is zero. Sometimes we do get one or two. So it is always less than 3 mpn per 100 ml. The surfactant which causes the foam on the water body, we are all hearing the Yamuna, the foam formation. It is because of the presence of anionic surfactants which are there in the detergents. So that also we are able to completely remove from the sewage. And then the total organic carbon, which represents this personal care products, antibiotics, and all those compounds. So that also is less than 10 milligram per liter, provided we administered about 5 milligram per liter of ozone dose. but that is again consuming more energy. So when we reduce the ozone dose to about 2 milligram per liter, then the TOC in the effluent goes to 15 to 20 milligram per liter magnitude. But still, I mean, for those who have curiosity, the TOC of the Kansavati river water, which we accept as a raw water source for IIT Kharagpur, is 30 milligram per liter. So this water is still much superior in quality as compared to the raw water available in the Kansavati river. But still, I am not calling it as a potable water because I know this around 15 milligram per liter of TOC is a culprit, and that is why I am calling it not calling it as a potable water. But somebody drinks this water by accident, nothing will happen. But everyday drinking is not really recommended because of the presence of these traces of antibiotic. Based on this experience, then I'm lucky that the IIT administration accepted our proposal to treat 1.35 mld of sewage generated from the hostel, which are located on the west side of the campus. And traditionally, we have been pumping that sewage to east side, nearly 3 kilometer, with the three stages of pumping station. That pumping itself is consuming energy. So to avoid that, we propose 1.35 mld sewage treatment plant right near the hostel so that the treated sewage can be brought back to the hostels for horticulture purpose. And we do have ponds on campus, so which get dried, face the water scarcity problem in summer. So this water, treated water, can be used for recharging these ponds during the summer. The cost of the treatment that we targeted, since our cost of water supply in IIT Kharagpur, this is 2021 costing, so 27 rupees per kiloliter. And since we kept the cost to be less than 15 rupees for treatment of the sewage, so that there is a net saving of 12 rupees, and that will fetch the revenue return, the return on investment within 5 years of installation of this plant. So based on this premise, we myself design. This is the PNI diagram of the plant. This is the plant when it was put in operation near the DVC gate of the campus. And this is the performance of the plant. Again, this plant, it is more than a year average performance. This is giving satisfactory performance. Except if you notice that the phosphorus, we have a regimen of polyelectrolyte dosing, but we are not doing it because majorly treated effluent we are using it for horticulture. And though the NGT recommended 1 milligram per liter of phosphorus, but this high phosphorus is welcome for horticulture purpose. So whenever we are using it for pond recharging, then we have to administer this polyelectrolyte dosing. Then the phosphorus concentration in the effluent can be brought down below 1 milligram per liter. Otherwise, this is okay. So this plant is also giving satisfactory performance with MPN, the pathogens presence less than 3 to 5 in the range. So it is much less than 100 recommended limit. And that way, satisfactory performance of this plant has been observed. And we at IIT Kharagpur are using this treated water. And you can see there is online monitoring system. So the performance of the plant can be monitored online. And these are some of the photographs of the online monitoring system in the last month. So see the BOD less than 10 milligram per liter and COD 25. Sometimes it gives around 35 to 32 milligram per liter of COD. So well within the limit of the recommended by NGT. Marginally, sometimes it exceeds 11 because the large size of the plant. So some fluctuation could be there. Then what is interesting is we worked on the life cycle costing of this plant. So 300 cubic meter and 1350 cubic meter per day. So the different cases we considered, suppose if we provide only primary and secondary treatment, then what would be the life cycle cost? If we provide ozonation, then what could be the life cycle cost? If we provide ozonation plus chlorination, then finally, of course, activated carbon filter, what will be the cost? Then ozonation instead of chlorination, only UV, then what could be cost? And when all three disinfection process in place, then what could be the cost of the plant? Life cycle cost of the water that is processed. All possible cost involved. in the operation of the sewage treatment plant, including plant construction, plant maintenance, periodic replacement of the component, perishable component like pumps, then diffusers, media, contractors' profit, third-party certification. All those costs we considered in the life cycle of this plant, even the administrative cost. So considering all those costs, we worked out the present worth of this, and then based on this, this will give you the idea. Suppose if we have only primary and secondary treatment in place, then the manpower component is the highest component, the cost component, capital cost is the second, and the energy is the third. Whereas when we are installing tertiary treatment, obviously the energy need is more and the energy demand. But whereas if you see the variation, when all three in place, the net increment in the energy cost is not much. So only about 10 paisa increment when all three disinfection process like ozonation, UV and chlorination are there in place. So we can get more reliable performance of the plant, and the life cycle costings comes out. For 300 meter cube per day capacity, the cost of processing sewage in the 2021 cost, I'm saying, so it is less than 16 rupees per kiloliter. And since the plant size is increased to 1350 meter cube, so we are able to produce less than 11 rupees per kiloliter the water, which is suitable to be reused on campus for any non-potable purpose. And IIT Kharagpur is happily using this water for fulfilling various water demand. And it is actually leading to the saving in the water pumping cost, as well as the saving in the pumping cost of the sewage, which otherwise we were doing to pump it to the oxidation pond 3 kilometers away from this location. Here onward, so far I shared with you the technology which are ready for implementation elsewhere. At the same time, parallelly, our emphasis is to work on the upcoming technologies, and we are among the recognized laboratories in the world for our contribution in the bioelectrochemical system. And the most popular configuration of the bioelectrochemical system is a microbial fuel cell. So the microbial fuel cell comprises of anodic chamber and cathodic chamber, where respective electrodes are housed. On anode, instead of methanogens, we target to culture electrogens. So these electrogenic microorganisms oxidize organic matter and convert it into protons, electrons, and of course organic carbon to CO2. And these protons are allowed to pass through the separator, which separates the anodic chamber and cathodic chamber through a membrane. Typically, it's a proton exchange membrane, which allows proton to migrate from anodic chamber to the cathodic chamber. The external circuit provided through the external load, whatever the device that we would like to power. So through that device, the circuit connects it to cathode. So there is electron flow externally towards cathode, makes the electricity flow happen in the other direction. That's a normal convention in the electrical engineering. On cathode, these protons, electrons are generally get combined with the oxygen, which is typically supplied through aeration to form H2. So this device can offer a convenient solution, affordable solution for treatment of the wastewater, simultaneously providing capability to harvest electricity while offering treatment to the wastewater. So this advantage of these BES systems are the sustainable green energy technology for wastewater treatment, ability to generate electricity from various wastewaters. Almost all wastewater which are biodegradable could be used as a fuel for this MFC. It converts chemical energy stored into the organic matter into the electricity in one step. High energy conversion efficiency is thus possible. It operates at ambient and low temperature, and hence there is no noise or other nuisance. Less sludge generation. So sludge generation is one third to one fifth as compared to the conventional aerobic process. It does not require any off-gas treatment as required in the anaerobic reactor, where the biogas is a combination of methane, CO2, H2S, ammonia, and many other gases. So that require gas reforming. So that reforming is not required here because our final end product itself is electricity. So no energy required for aeration provided. The cathode is configured as a air breathing cathode. So directly oxygen from the air can be breathed by the cathode. So with that configuration, there will not be any aeration cost involved. So that way it will afford reduce the operational cost. So though this technology looks prima facie exciting, but there are challenges. The challenges are a single MFC gives about theoretically can give 1.1 volt. But because of the involvement of activation loss, concentration polarization loss, and ohmic loss, the actual voltage that we can obtain ends up around zero point 0.5 to zero point 0.6 volt. So single MFC will not give us usable electricity. So we need to have devices in stack. If I have target of integrating voltage, then I need to connect them in series. If I have target of integrating current, then it has to be connected in parallel. But when we are connecting in series or parallel, then the stack itself has a problem of overshooting the potentials, and then the system may not give the adequate performance. So the challenges scientists are working all over the world, and hence that poses a scaling up challenge. Like I can have 300 to 400 meter cube size single USB reactor for biomethanation, whereas here because of the involvement of electrochemistry, I cannot have more than 20, 30 liter volume of the single device. And that way, if I have to treat 1 mld of the wastewater, and if I have to use MFC as a technology, I will require multiple MFCs, and handling those in a stack and feeding them in a stack itself would be challenging engineering challenge. And we need to find solutions for that. Expensive electrode accessories and costly separators, the separator, the proton exchange membrane that I talked about, if we use Nafion, which is the popularly used separator product of DuPont, so that cost in India around 1700 US dollar per meter square. So imagine if using such a costly component, if we try to scale it up, the cost of this MFC would be 10 times higher than the other alternate treatment technologies. So we need to reduce down the cost. Also, the platinum, which is popularly used as a catalyst on cathode in electrochemistry. So platinum is another precious metal, costly metal. So for wastewater treatment application, even recommending platinum will enhance the cost of this device. Then there are the other challenges like pH imbalance, current fluctuations, and higher internal resistance. So which are typically there in any biological reactor. And high maintenance cost by using such Nafion membrane, which will require periodic maintenance and replacement. Here, what it shows, I mean, the first paper on MFC was published in 1911 by Potter from UK. Then the second paper in 1935, third paper in 19, sometime in 1965, fourth in 80s. And since 1999, then there are the attentions have been paid by the scientists, and you can see then there is a surge in the publication. And till this month, there are around 1700, 700 papers which are published as per the Scopus database. And this is where our research group stands. After Bruce Logan from the Penn State University, our research group from IIT Kharagpur has contributed more than 200 articles addressing different issues related with the development of these microbial fuel cell and bioelectrochemical systems. And as the institution, IIT Kharagpur ranked fourth. The first two are Chinese funding agencies, somehow listed by the Scopus as the institution. But institute-wise, after Harbin, Penn State, then we are the fourth in the world for contribution in this domain. So nearly 20 years of our research efforts at IIT Kharagpur, we did research on the ceramic membranes instead of Nephron. So the clay pots or clay utensils that we are using, clay itself has a natural cation exchange capacity. It may not be specific for proton, but cation exchange capacity also helps in the proton migration by allowing the hopping mechanism for proton to transfer from one side to other side. So we tried with the different soil collections, and we realized that the clay with the montmorillonite minerals, if we add with the 20% montmorillonite, so this ceramic membrane could establish the similar properties as compared to Nafion, and at much cheaper cost. This ceramic membrane can be produced, 1 square foot membrane can be produced at the cost of 20 rupees, whereas the Nafion is costing me 1700 US dollar per meter square. So imagine compare the cost. So this is one of the breakthrough. Then secondly, this device is being challenged by the growth of methanogens. Though we target electrogens to grow in the system, so the methanogens also grow in the similar environmental conditions. So they will also dominate in the system, and methanogens will consume substrate and produce methane rather than allowing electrogens to consume substrate and produce electricity. So we came out with the natural solutions. Other scientists have used chemicals, but when I'm saying that this is a wastewater treatment device, and if I am adding some toxic chemicals there, at downstream I have to treat for those chemicals, which will be more costly affair. So we came up with the plant-based solutions. So natural plant extract, eucalyptus extract, or some of the selected algae extracts could suppress those methanogens. And periodically dosing of those plant extract, we can control the methanogens growth. And also experimented with the multimetal oxides cathode catalyst. So that will also reduce the cost of cathode catalyst, because typically the carbon is the material that is used for the anode and cathode, because it is a stable material, biocompatible material, but it has a sluggish oxygen reduction reaction capability. So some metal catalyst is required to enhance the oxygen reduction reaction on the cathode, and multi-metal cathode catalyst like CuSN. So all those can be at much cheaper cost, can provide reasonable oxygen reduction reaction and hence the cathode potential. So with this about more than 17, 18 years of research experience, then we came up with the concept what we call it as a bioelectric toilet. So sewage generated from the toilet will appear into the first central compartment. For simplicity, the empty reactor I am showing here. So first sewage comes here, hydrolysis of the solids will occur here, and then half of the sewage will be allowed to flow through the clockwise direction through these peripheral chambers, half through anti-clockwise direction through this peripheral chamber. And these are the what you can see, the black squares. So this is basically the carbon filter. Below that there is a ceramic separator and a pairing with the anode, which is again a carbon filter. So these electrodes, cathodes are coated with the different metals for experimentation purpose. And while it comes to the final chamber, we are dosing it with the hypochlorite. So the hypochlorite itself work as a catholyte, or hypochlorite also contributes for disinfection, producing final treated effluent, which is suitable to be reused back in the toilet for flushing. So those who are not aware, if we use contaminated water in the system for toilet flushing, there is a risk that 1 in 100 person can be infected, because we may not realize, but small droplets while we flush the toilet, small droplets spread on our body. And if we use the contaminated water, then there is a high risk of waterborne disease, catching waterborne disease. So even for flushing toilet, the water that we use should be free from pathogens. And hence, this system is providing less than 100 mpn per 100 ml effluent using different cathode catalyst we experimented, and this is the performance. I mean, the treated water has BOD less than 23 milligram per liter, COD less than 80 milligram per liter, and MPN all along. This is 2.5 year performance result I am averaging, so less than 100 MPN. So that makes it water suitable to be reused back in toilet for flushing. So once in a day, we are pumping it back to the toilet by using solar power pump. And that way, once you flush the toilet, the equal amount of treated water will be displaced from the system. And once in a day, we'll pump it back. So this will that way impart the water consumption in the toilet will be significantly reduced, and it can classify as a water saving toilet. So people are reluctant to use the toilets which are constructed in the remote area. People are reluctant to use those toilets because of the water scarcity, and that leads to the filthiness in the toilet. So people are not using those toilets. So if we install such system, so the water will be always available, and Indians are typically cleaners. We use water for cleaning. So half a liter or 1 liter of water that we use every use of the toilet. So that will compensate the evaporation loss that is occurring in the system. And this way it will be perfectly make it as a water-free toilet. So then the electricity which is generated in the process, the electricity can be used for illuminating toilet premises at the night and even toilet cabin at the night. So this way, the fearless use of the toilet can be encouraged. So women and children's infants are typically reluctant to use toilet at night because of the attack of insects. So if we eliminate the toilet premises, so that fear will also go away, and that will encourage the use of the toilet. So since I said the each device, each pair of the anode cathode arrangement generates only about zero point 0.5 volt and some current. So we use power management system, so which is comprising of four capacitors, each having 500 capacity. So when they are getting charged in parallel. And once you put on the switch, the circuits connect them into the series so that the electricity can be enhanced to illuminate the LED lamps. So we had another installation at NTPC Netra campus in New Delhi, and there also for their guest house wastewater generated from the guest house, we could treat successfully for 2 years, and they are also happy with the performance of this MFC-based treatment system. As I was talking, the microbial fuel cell system, this BS can also be configured as MFC plus desalination system. So instead of two chamber, if I use anodic chamber, which is operated in the similar fashion as the MFC, cathodic chamber is also operated in similar fashion as MFC, but there is a separated chamber, what we call it as a desalination chamber. So that is housed in between the anodic and cathodic chamber. So either the same wastewater can be applied here to facilitate desalination if any industrial wastewater has high salt concentration, or saline water can be admitted to facilitate desalination. Because of the potential difference between anode and cathode, the charge migration also occurs in this system, and the anions will get migrate towards anode, cations will start migrating towards cathode, and that will help us in desalinating the wastewater in the middle chamber. So we had a project from Tata Steel for their in the steel industry effluent. We use five chamber MDC for that purpose, and using actual steel industry wastewater spiked with Pseudomonas aeruginosa microorganisms, what we call it as a bioaugmentation, we could get very satisfactory performance of COD removal 80%, coulombic efficiency, the electricity harvesting efficiency around 14%, TDS removal from the actual industrial effluent up to 78%, which is acceptable for them. So they are not looking for 100% TDS removal as performance will be given by RO, but lot of reject it will generate. So without any reject, we are able to raise up to 78% TDS removal efficiency, and simultaneously able to harvest electricity while treating that wastewater. Now I'm working with another project from the Praj industry for scaling up of this device, and that work is on. The last technology which I would like to demonstrate is a microbial electrosynthesis. So the MES could also be another cleaner or sustainable approach for capturing CO2 and converting into the various chemicals. Uh, or CO2 generated from the wastewater treatment plant itself can be captured and used, or the CO2 present in the flue gas of the industry, which is of the order of 12 to 20%. So that can also be captured and can be converted into various value-added chemicals using this microbial electrosynthesis system, where we use microbial life for facilitating reduction of CO2. We all know there is a thermodynamic limitations, and because of that, the natural CO2 reduction is not possible, and that will require some external energy to overcome that barrier, thermodynamic barrier. And for that purpose, we need to impose, instead of harvesting electricity in this system, we need to impose potential, typically less than 1 volt, to take those reaction forward. Acetogens or whatever the microorganism that we target are typically cultured here on the cathode. In the anodic chamber, we may treat wastewater, or most of the scientists are using fresh water, where water splitting occurs because of the protons and electrons separated. Electrons are diverted towards cathode, protons in the similar fashion as in MFC allowed to pass through PEM to reach to the cathode, and on the cathode, with the help of the imposed potential, this acetogenic microorganism can help in synthesizing acetate or other, depending upon the type of microbes grown. High chain compounds can be synthesized. Scientists have reported successful synthesis of formate, acetate, again formate, ethanol. And in our lab at IIT Kharagpur, successfully acetate, isobutyrate, propionate, piperidinone could be synthesized by imposing about 0.9 volt potential. Then one of the largest MES 2 years back is demonstrated by my research scholar Dr. Das, which is 12.6 liter capacity. So the idea here was the USB reactor, the biogas produce, it typically has about 35% carbon dioxide. So we can pass this biogas through this MES and the carbon dioxide can be utilized. So that will help in reforming the biogas and enriching the methane content in the biogas. So biogas leaving this MES typically had more than 80% of methane. So complete enrichment could not occur because of the thermodynamic limitation, and multiple reactors will be required for further increasing the methane content in the biogas. But at the same time, what is important is we were able to successfully synthesize acetate using this carbon dioxide, which otherwise get released into atmosphere. And at present, though, that time the yield was only around 400 milligram per liter. Now, the present research scholar using different catalyst and different reactor configuration, we are able to reach up to 2.5 gram per liter of acetate synthesis using this MES system. So this is it. So I look forward for the knowledge dissemination, providing knowledge-based support to the industries, all the government and other research scholars, and also training manpower for operation and maintenance of STPs. These are some of the books recently authored or edited by me. And thanks to my young research scholar group for their hard work to produce all these results, which I shared with you today. And thank you all for your patient listening. And thank you, Professor Acharya, for giving me this opportunity to present the work that we did at IIT Kharagpur. Thanks a lot, sir.
Thank you, Professor Hangrekar, for such an excellent presentation of your work. And I will now request the participants who are present, if they have got any questions, please go ahead. I don't find anything in the chat box. Please raise your hand or just ask the question.
I will stop sharing. Yeah, that's better.
Any question, please? So I think actually there is no question from the audience side. So I would like to raise a couple of things from my side.
Okay.
One thing, that is the topic which you have handled, very, very interesting, and a lot of things can be done. And in fact, I think our country requires the treatment of actually what sewerage water, because water scarcity is definitely going to come. Many areas are actually water stressed, and we cannot really afford to waste all these things. So, first of all, the objective of any sort of industry now should be to make it water neutral.
Yep.
That means water. Now, to the best of my knowledge, there is one industry in this Kutch area,
Yeah.
that is actually Tata Chemicals,
Mm-hmm.
where there is no rain, nothing of that sort, but they produce so many chemicals and also produce salt, whatever that we take, Tata salt. Okay. All using the seawater and utilizing it, and what they give is actually drinking water to the colony, and also the, for horticulture purpose, everything.
Yeah.
So that is actually one thing which they've done by doing this one. The second one which comes to my mind is this in Bombay, RCF.
Yes, sir.
Yes, it gets only this, sewage water.
They
And
accept sewage, raw sewage.
And also they supply water to BPCL, their next door thing one.
Yes.
That is in the large scale, actually, whatever we have. Now, my question is, to what extent actually this technology has been used in this Ganga cleaning effort? Any one of them, which is, please.
Ganga cleaning majorly now presently most of the technology most of the plants that are installed, they are SBR based treatment, sequencing batch reactor. So some of the plants are even MBBR based, but SBR typically cost about 1.5 times, my experience, about 1.5 times than the technological solution which I provided. And the reliability, what I want to say is almost similar. I mean, I also operated this plant for more than 2 years, and reasonable reliable performance is guaranteed. SBR, the advantage is it is automated system, so complete automation is there. So that is why, since there is no human intervention, so the reliability is more. Obviously, I do agree, but then at 1.5 times higher cost. That is because I also design and check many of their SBR based sewage treatment plant. Let it be in the Jharkhand or even the recent times in Bihar also, even in Chhattisgarh also, Raipur and their extension. These are all SBR type technology because those companies are aggressive in marketing. Other companies are lagging. So that's the only reason I feel.
I understand actually then most of the conventional technologies which are being used in the developed countries, they are very costly also. That is quite understandable. And therefore, actually, we have to develop the newer technology which could be sustainable as well as actually cost effective. For instance, I know
even for rice mill wastewater treatment. I mean, I did consultancy for 4 rice mills in and around Bhubaneswar, and now the client was telling they have installed more than 220 plants with the USB and MBBR based treatment system for facilitating treatment and recycling of their water. So happily they are using, and it is in operation more than a decade now. So people are happy.
one thing which I'm aware of, that is then actually in the Los Angeles area.
Sir.
And that is in Irvine.
Okay.
In that Irvine is whatever actually the sewerage water that is fully treated, and almost something like 15 million gallons per day. That amount of water, it is again recirculated, and people use it actually drinking water. But that is all costly. It is possible theoretically, but definitely very, very energy intensive.
Singapore they are doing. Singapore also they are doing. So they are indirect use. They are sending it into the pond, and from pond they are accepting for public water supply. And new water is directly sewage treated water.
Yes, yes, Professor. Actually, you have got actually some question to ask. Please.
Yeah. Yeah. So first of all, thank you very much. It was very informative. Especially, I have at one time at TRDDC, we were very deep into water and all that. I am in Pune, and Tata R&D Design Center, you may have heard, they have done a lot of work in water, and basically affordable cost is the main issue in India. I have so many questions, but hopefully we will meet sometime. I would like to discuss with you because
take your own time.
because we have so many, nothing has really, there is no success story. I mean, including ours in TRDC, our group worked so hard at it. So I had very specific question, which I just wanted to sound with you because you are very deep into this. You know, in Pune there is this Mulamutha River, which is kind of international news. There are so many articles, even in regular media, because
Yes.
this water hyacinth grows like hell and
Yes.
it creates mosquitoes and all that. And we had at one time worked on water hyacinth biomethanation. I mean, our group in TRDDC colleagues, they had perfected reactor and in fact scaled it up. In fact, our colleague Dr. Meher even had worked with defense, and they had, even for excreta, human excreta in Ladakh, they had put up a plant and all that. But ultimately it turns out that for water hyacinth it is not commercially viable because water hyacinth does not have enough organic matter so that the whatever gas is produced, it is not. So I looking back all that work we had done, we I was all the time thinking that instead of biomethanation of water hyacinth, why don't we do research and find out why water hyacinth grows in Mula River? And
Exactly.
then after some investigations, it occurred to me that it could be because of nutrient. And
Yes.
I saw in your talk, I've been trying to convince various people that why don't we take it up and see that we prevent nutrients entering Mula River so that we can prevent water hyacinth production.
Absolutely.
I am just wondering, in your technology solution, is there something which can recover this and P and I mean NPK basically, and so that obviously there is a sewage which is being dumped into Mulamutha River, obviously, because we hardly have, as you rightly pointed out, we hardly treat any sewage treatment. I mean, it is just mind-boggling. As an engineer, I feel so ashamed, that we are talking about all kind of things and we are not even treating our sewage. So question is, in your technology, would it become economically viable and we can recover nitrogen and phosphorus? Because I just saw that you are doing that.
Yeah, to respond to your query, I mean, I'm very much aware of Pune because prior to joining IIT Kharagpur, I was with the College of Engineering Pune, the
Oh,
lecturer there.
really? Oh my
Yes.
God. I see. Okay, so we
And
may have
I'm
met.
also aware of your research group. Tata Swachh is one of the product which
Yeah,
is
correct.
launched by your group. And
Yeah.
that time I was interacting, and sometimes in the conferences I keep interacting with the people from your group
Oh,
as well.
great,
So
great.
then coming to this Mula Mutha, see, we
Hmm.
can install the plant. I mean, I can design, I can provide design, and that one of the alumni funded project. So
Hmm.
canal top treatment plant. I mean, a very
Hmm.
compact treatment plant without using much costly devices. Where I also use aerobic and anaerobic MBBR. And a compact design, modular design can be installed right on the river bank itself. But some barrage
Hmm.
has to be there so that we treat
Hmm.
water on one side and then discharge it treated water on the downside, and at
Hmm.
much lower cost. I mean, the cost of the plant will be cost of the treatment would be less than 10-11 rupees per kiloliter again,
Hmm.
upfront cost. But based on the plant size, we can work out.
Hmm.
The third point you ask is recovery.
Hmm.
Recovery recent, it's a last 10 years scientists are, rather than treating, now they are showing attention on the recovery. As I
Correct.
showed the photograph of the PNSB, purple non-sulfur bacteria harvesting or algae
Hmm.
harvesting. Algae is
Hmm.
almost now matured. I mean, there are raceway ponds which can be designed, or a high rate algal pond. Complete design is available. So, if immediate solution, if you want, then the algae is the best. In which form the nutrients can be harvested. But again, the area, it demands more area.
Hmm.
So we are trying instead of algae with the PNSB. But as I said, it is the first of the plant of this size out of the lab.
Hmm.
So still a lot more. I mean, it will require another 3-5 years of effort for this technology to be matured. I mean, small things. I mean, those PNSB has been liked by even our snakes and other things, other insects. So they
Hmm.
come to the plant and eat away the biomass. So that is the first problem that we face. So now we covered it completely. Other insects are happy eating that biomass. So there are typical challenges which will be faced by when we operate in the full scale. But as I said, I mean, if we have this problem, we can work together and find out the solution. Solutions are there. Only
Yeah,
thing is there is a will.
no, it just occurred to me, and I did not know that you are COP alumnus. So we have Praj here. In fact,
Yeah,
at one time we
Dr.
had
Sham,
interacted.
Dr.
Uh,
Sham is there, I could say.
yeah. Praj Industries is there where they are very much into algae, water. I mean, I have seen their plant. They were working at that time algae for other. So we can sort of work out, and you are already working with Praj, so we can take it up and at least demonstrate something which is economically viable or something. I will
Definitely, sir.
come back to you. I am
Sure.
sure I will be able to find your contact details, and
Yeah.
I will talk to people here, and then we should. I mean, I feel we should be able to scale it up something which is commercially viable. I mean, even though biomethanation has been some company, but it has not gone the way it should have. I mean, in
Yeah.
India, there is so much agriculture residue, waste, water, all kind of things, but we have long way to go. But I'm glad that you are so deep into it and you are working with industries, and we should be able to scale it up. Yeah. Thank you.
We can design. I am very much confident of designing bioreactor, USB reactor for biomethanation. And I have several designs. I mean, more than 2 dozens in and around Pune designs I have. So typically in
Yeah.
Aurangabad, Nashik, those regions.
And this microbial fuel cells also, I mean, the government has such a big program on biofuels and all that.
Yes, yes, yes.
I'm sure you must be in the loop already. I mean, that also can be explored further, because I am not an expert in this area, but I have been reading so much about this microbial fuel cell. So I'm very glad that you are expert in that, and I think it looks
So,
like it has a future. Yeah.
so far, there are more than 12 pilot scale reactors all over the world. And I'm happy
Hmm.
to share that half of them are using the ceramic membranes, what we
Correct.
developed, because that
Correct.
makes it a very low cost. And
Right.
actually, that is giving us business. I mean, the joke part of it is the potter was contacted by the UK people, and now he realized it's a something precious material. So instead of 20 rupees piece, now he's selling it to 30 rupees a piece. So he realized.
Yeah. 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 I mean, water is such a basic necessity. I think there should be a mission clean water or something, and
I
some of
absolutely
these
agree.
technologies should be, made available. I mean, I shall look forward to meeting you sometimes if you
Yeah,
are.
I just shared my email so you can reach me. I mean, in the
Sure.
chat box, I
Okay.
shared the email address. Yeah.
Okay, thank you very much. Yeah, and
Thank
all
you.
the
Nice
best
talking
to
to you.
you for commercialization of these
Thank you so much.
technologies. I hope
Thank you,
in
sir.
my lifetime I will see some of these things
Thank you,
go
sir.
great.
Thank you, sir.
Thank you.
Sanat Kumarji, you were there.
Yes,
Please,
sir. Yeah,
please ask your question.
yeah. I'm sorry.
Namaskar.
This may be a very naive and not an expert question, but I just thought this thought occurred to me, so I'm putting it out.
Sir,
I
your
work in
image
the.
is not coming clear. Please,
Sorry,
your
sorry.
your image is not clear. Sound is clear.
Yes, sir.
Ah,
There is some problem with the camera, but
Okay,
anyway,
okay. Please go ahead.
my issue is like this. This sludge, waste sludge. I thought the BRC had developed one system by purifying it with the radiation treatment. And I think they did something in Kuam River in Madras.
mhm.
So how does it fit in this place? Sludge treatment by biological sludge waste treatment by radiation. It was supposed to kill all the disease-causing organisms.
Yes. It will radiation will definitely kill all pathogens, but the end product forms because radiation is means we need to be extra careful. What are the end product form? Without detailed analysis, it's very difficult to certify. because sludge is not a homogeneous mixture, though majorly it is dominated by the microorganism, but there are other subtle ingredients as well. So how they will respond to this radiation, I mean, that detailed study is required. So scientists are doing hydrothermal process also in our lab. My research scholar is working on biochar production, hydrochar production from that sludge. Even we at our lab, we tried with the ultrasound. Our colleagues from other IITs are doing with the other technology, as I said, hydrothermal process. So we have to spend energy for killing those pathogens. Then only the sludge is suitable to be reused downstream. But when particularly radiations that we are using, we need to be extra careful because it will not completely oxidize everything. It will
Yes.
convert it into intermediate products, which may be more dangerous. And if there is a residual radiation left, I don't know. I mean, I'm just populating the doubt. So we need to certify.
No, I, I still have the doubters. What I'm trying to say is, I think BRC made a pilot plant, and we
Yeah.
have a atomic energy regulatory board. So as you
Right.
said, the output should have been certified by the regulatory board. Otherwise,
Exactly,
it cannot
because it is
go
released in
forward.
environment. Yes.
Yes. So I do not know whether it. I was just wondering whether you are aware of what is the status on that. That's all.
Thank you, sir. Thank you for
Okay.
your concern.
Thank you, sir.
Okay. Any other question? I have a small piece of information. Professor Gangrekar,
Sure.
you must be knowing it very well. In Pune, there is one National Institute of Bank Management,
Okay.
NIBM.
Hmm.
That is actually
Yeah.
RBI thing institution.
Yeah.
And in that institution, I have seen in early 80s, personally went there, that they have been really treating all these sewerage and not utilizing actually for the drinking purpose, but they are all other horticulture need, that need actually that has been really, it was
That
to
was
a
a good
great extent
initiative. Yeah.
sufficient for them. This is, I am referring maybe in 83, 84, that time. So
Yeah.
that was actually one of the earliest thing where this sewerage treatment I could see.
Yes, sir.
Anyway, now we have to formally actually propose a vote of thanks.
Thank you.
I have great pleasure in proposing a vote of thanks for this to Professor Makarand Madhav Gangrekar, who has so nicely explained to us so many technologies which he has developed and which are being practiced. And these, many of them are actually available in IIT Kharagpur itself. So for the treatment of actually sewerage water, sewerage, and making the, output at least usable for various purposes, including actually drinking also. So the entire abstract actually is all with you. So you please actually go through this. So it was really very much illuminating discussion, and beautiful questions also came up. So I must really thank you, Professor Gangrekar, and also all participants who really joined this thing. I also take this opportunity to thank our other cooperating organization like, let us say, IIT Bhubaneswar, IIT Niger Bhubaneswar, IMMT Bhubaneswar, and the IEEE chapter of Bhubaneswar, for their all cooperation, and with all their help, actually, we are able to conduct this series of lectures. So I must profusely thank Professor Gangrekar to you for
Thank you, sir.
bringing so many new things to the table. So I'm sure people will really like it, and some of them may use it. So with these few words, I thank you all who are present. if you can really, those who are present, you can put on your video, we can take a photograph. Hello. Very good.
Thank you.
Professor P.K. Misra. Okay. Thank you so much. Namaste.
Thank you, sir. Namaskar. Thank you. Thank you.
That
Thank you.
We'll actually send you a small memento by post.
Okay,
That
sir.
will be
Thank you.
from the
So
SOA
nice of you,
University side. Okay.
Okay, sir. Thank you. Thank you, sir.
Thank you.
Jai Hind.
Don't